Good morning, dear students and all the viewers. It's me, Indramani Gewali, Math Facilitator. Welcome you all in the live telecast of JanataTelevision for distance education. So let me recall our previous class. On Sunday, we started from a chapter mensuration, and I discussed about what is mensuration, what are the uses of mensuration in our daily life, and then we moved into the topic plane surface, because plane surface is the first topic of grade 10 mensuration. So after that, under plane surface, I discussed about triangle, and in triangles especially I discussed area of triangle in terms of its base and height, and area of right angle triangle and their perimeters. So today let me connect with the same topic, plane surface, and today's main objective is, after taking this class we will be able to learn what are equilateral triangle and isosceles triangle, how do we find their areas, their height. We will discuss on this. So let me begin from a topic, area of an equilateral triangle. So for this, let's draw a triangle. So let's draw an equilateral triangle. In equilateral triangle, all sides are equal. We know there are three sides in a triangle. So this is an equilateral triangle. Here, three sides are AB, BC and AC. They are equal in length. And we can denote, if we denote side of an equilateral triangle by A. So what is A? A is the length of side of equilateral triangle, each sides of an equilateral triangle. So here, to find the area and perimeter of an equilateral triangle, especially to find the area of an equilateral triangle, there is a special formula, because we can find area of triangle by using a formula 1 by 2 times base times height. But in some of the cases, like in equilateral triangle, isosceles triangle and scalene triangle, we can use some special type of formulas. So let's derive a formula to find area and height for this type of triangle. It's equilateral I am discussing. So for this, let's draw perpendicular or height from the vertex. Let me write this point is D and base side is A. Equilateral triangle has a special feature. Here in the figure, AD is perpendicular length drawn from vertex A to the opposite side BC, and this is called height because it's perpendicular. So in case of equilateral triangle, a perpendicular drawn from a vertex to the opposite side always bisect the base, or we say this is perpendicular and bisector. Perpendicular bisector of the base BC. So AD is perpendicular bisector. So if AD is perpendicular bisector, here we can denote height by H. AD is height. Now what is the length of line segment BD? It's A by 2, or we can write here what is BD, A over 2, and what is DC, A over 2. Because total length A is equally divided into two parts. So what is the half of A? A by 2 and A by 2. So here in the figure we can see two right angle triangles. These are triangle ADC and triangle ADB. If one of the angle D, this angle is 90, so this side should be 90, because sum of two angles in a linear pair is 180. So let's take a triangle, right angle triangle ADC. and we can find the height in terms of the side A. So here AD is perpendicular bisector of BC. So if we suppose AB is equal to BC is equal to AC, this is A, because I am supposing length of each side of this equilateral triangle A. Now what is the measure of BD? BD and DC are half of BC, so this is A over 2. Now if we just look at a right angle triangle, let me take a triangle ADC. We can use one of the right angle triangle. Here I am using triangle ADC. So in right angle triangle ADC, in right angle triangle ADC, so what is the hypotenuse? Hypotenuse is a side which is opposite to right angle. This is AC. Perpendicular is AD, and this is height here. And what is the base? DC. So if we use a Pythagoras theorem, we can find height. So by using Pythagoras theorem, let's write AC square is equal to AD square plus DC square. This is, we know what is Pythagoras theorem. H square is P square plus B square. Let's not get confused. H is not the height here. H is hypotenuse. So let me erase this. Otherwise, we may get like confusion. Here, H is square or H is hypotenuse. This is the longest side of a right angle triangle. And in the figure, AD is the height for this triangle. Now what is the length of AC? So AC is A, or A square is AD, we are calculating for AD is square, plus DC is, what is the length of DC? It's A by 2 whole square. So let me write on the top. So let's simplify this and get the value for AD, or A square is AD square plus, what is A by 2 whole square? A square over 4. Now we can take A square over 4 in the left hand side because these are the like terms. So A square minus A square by 4 is AD square, or we can take LCM in the left hand side. So what is the LCM? Here 4. So 4A square minus A square is AD square. Let's simplify this and find what is AD. AD is the height, so we are calculating for AD. This is 3A square over 4 is AD square. Or now if we take square root on both sides, we can find AD. So AD is square root of 3A square over 4. So this is, it gives us square root of 3 over 2 times A. So this is AD, and this is called height. So after finding the height of a triangle, now we can simply find its area. So here I am deriving a special formula for an equilateral triangle that will make us easy for the calculation, for calculating area, if you know the direct formula for an equilateral triangle. So AD is, this is height. So what is the height? Is square root of 3 over 2 times A. where this small a is length of side of a triangle. Here length of side of an equilateral triangle. So after knowing AD, now what is the basic formula to find area? So area of triangle ABC is, formula is 1/2 or 1/2 times what is its base, BC, times height is AD. So 1/2 times what is the length of BC? It's A, times what is AD? AD is square root of 3/2 times A. So if we simplify this, we will get √3 √3/4 times A square. So area of an equilateral triangle can be calculated by using this formula, is square root of 3/4 times side square. So we can take an example for this. Let's take one example and find area of an equilateral triangle. This is the formula we use for an equilateral triangle. So let's take an example. Find the area of an equilateral triangle whose side is 4 centimeter. So this is example. So I am taking here. Find the area of an equilateral triangle whose side is 4 centimeter. Means 4 centimeter is the length of side of a triangle. Its side, it's same, because in equilateral triangle its sides are equal in length. So let's solve this. Here let A be the side of an equilateral triangle. Here A is the length of each of the side. Of an equilateral triangle. So A can be either AB, AC or BC. It's same. So what is A? So A is 4 centimeter. This is given. Now what is its area? So area of equilateral triangle is, let's write the formula for area of an equilateral triangle. So area of equilateral triangle is square root 3/4 times side square. So what is A? A is length of a side, it's 4, so 4 is square. Now we can just calculate this and find its area. So let's calculate what is the area. So area of this equilateral triangle is square root of 3/4 times, what is 4 is square? It's 16, so we can cancel 4 and 16, or A is 4 times of root under 3 is square units. So this is square units. So here what is the unit of length? It's centimeter. So therefore area is 4 times square root of 3 square centimeter. So this is the way how we find area of an equilateral triangle. So similarly, if we are given perimeter of an equilateral triangle and we are asked to find area, we also can use perimeter, concept of perimeter, and then again formula of area to find the area. So talking about plane surface or triangles, we talk about area and perimeter. So if I take an example here, if I take an example like the perimeter of an equilateral triangle is 12 centimeter, and what is its area? Let's do next question. The perimeter, so I'm talking about equilateral triangle. If perimeter of an equilateral triangle is given 12 centimeter, this is perimeter of an equilateral triangle, and we are asked to find area. Area is asked. Now to find the area, what do we need to find the area? To find the area of an equilateral triangle, we required its side. So for this, we can begin from perimeter. So what is in fact perimeter? So perimeter of any triangle is sum of its all sides. So here we suppose the length of each of the side of an equilateral triangle is A. So what is perimeter? Sum of three sides. So we have, what is perimeter? Perimeter is sum of three sides, so it's 3A unit. So A plus A plus A is 3 times of A. So what is the perimeter? Here perimeter is, it's 12 centimeters, so we can replace this 3 times of A, or A is 12 by 3, so therefore A is 4 centimeter. So A is length of each of the side of an equilateral triangle, it's 4 centimeter. Now can we find its area? Obviously we can find, because the same question we have already discussed. So the main concept is, if we can begin from the information that is known, here perimeter is known and area is unknown, so we cannot directly start from the formula of area, because a parameter that is required for area is unknown, which is length of a side. That's why we started from perimeter and we calculated the length of each of the side. Now we can use direct formula of area. So what is the formula of area of an equilateral triangle? Area of an equilateral triangle is square root of 3 over 4 times side square. Simply we can put A, it is 4, and we can calculate the area. So let's do it. It's similar with the previous one. Now let me move into the next special type of a triangle, isosceles triangle. Now we will discuss what is isosceles triangle, what is area, how do we find area and its perimeter. Let me move into the next type, area of an isosceles triangle. Isosceles triangle. Let's draw a triangle here. So in an isosceles triangle, let me give name to the triangle. ABC is an isosceles triangle. In isosceles triangle, any two sides are equal. Any two sides are equal, and we know there are some special features of an isosceles triangle. Two sides are equal and the base angles are also equal. And let me denote the equal sides of an isosceles triangle is by A and the remaining side or base by B. So what is small a? Small a is the length of equal sides of isosceles triangle. Here AB and AC are equal, so both sides are denoted by same A, which are the equal sides. And what is small b? It's base or the third side, or we also say remaining side of an equilateral, sorry, of an isosceles triangle. Okay, so here again I am going to derive a special formula for isosceles triangle, but we can use the common formula 1 by 2 times base times height, but for some triangles like isosceles triangle, equilateral triangle, there are some special formulas that will make calculation easy. So let's derive what is the special formula to find area of this triangle. For this, let me draw perpendicular. So in isosceles triangle, there is a special property of isosceles triangle. The bisector of the vertical angle. Here the vertical angle is A. If a line bisect the vertical angle A, the bisector of the vertical angle of an isosceles triangle is perpendicular bisector of the base. This is again one property of an isosceles triangle. If it's bisect vertical angle A, then the perpendicular bisect the base. So if this is AD is height, because height is perpendicular to base and drawn from one of the vertices of a triangle and perpendicular to its opposite side. So if AD bisect the base BC, what is the measure of BD? Again, BD is half of B, it's B by 2, and what is DC is again B by 2. We can see here are two right angled triangles. Let me take a triangle ADC, like in previous equilateral triangle. So I am deriving first of all height AD, and then we can get the special formula for this isosceles triangle. So here let AB and AC are equal sides. I am supposing to equal sides by A and its base BC by B. This is my supposition. So I am taking a triangle, or in triangle, this is a right angle triangle ADC. In triangle ADC, so what is the length of DC? This is half of BC, so we can see in the figure it's B by 2. So if we use Pythagoras theorem in a right angle triangle ADC, now we can find the height AD. So let's use Pythagoras theorem, which is AC square is equal to AD square plus DC square. So this is in fact Pythagoras theorem. H square is P square plus B square. H is hypotenuse, P is perpendicular, and B is base. So what is AC? It's A, so A is square. A is AD square, AD is unknown, plus this is B over 2 whole square. So let me erase and write here on the top. And we are simplifying for AD, or A square is AD square plus B square by 4. Or if we take B square over 4 in the left hand side, A square minus B square over 4 is AD square. Or let's take 4 LCM. 4 times A square minus B square is AD square. Let's simplify this. Now simply we can see on the right hand side it's AD square, and we are searching for AD. For this we can take a square root on both sides and find AD. So therefore what is AD? So AD is square root of 4A square minus B square by 4, or therefore AD is, what is square root of 4? It's 2. So 4A square minus B square over 2. This is the height. Now actually I am deriving formula for area of an isosceles triangle. Now, what is the area? We can find. Therefore, area of an isosceles triangle is the basic formula of triangle is 1/2 of base BC times what is height AD. So 1/2 times BC is what is BC? B times what is AD. So AD is square root of 4a square minus b square over 2. Let's simplify this. It's b by 2 times of 2 is 4 multiply by square root of 4a square minus b square. So this is a special formula. B over 4 times square root of 4a square minus b square, it gives area of an isosceles triangle. So if we know A and B, so what are A and B? A is the length of equal sides, each of equal sides of an isosceles triangle, and B is third side or remaining side, or we also say this is base. So knowing these two values A and B, we can find its area. So let's take a example. In isosceles triangle, if A is 6 centimeter and B is 4 centimeter, what is its area? I'm talking about isosceles triangle. So area of an isosceles triangle is b over 4 times square root of 4a square minus b square. So what is base? It's 4 over 4 times square root of 4 times a squared is 6 square minus b square is 4 square. So it's 1 times 4 times 36 minus 16. It gives a square root of 144 minus 16. This is square root of 128. Similarly, we can find area of the triangle when A and B are known. So this is what is the unit of side centimeter. This is cm square, and we can take out from the square root. Okay, so today we discussed about two different types of triangle. We derived special formulas for equilateral triangle and isosceles triangle. Similarly, there is one more type, scalene triangle. So in scalene triangle, none of the sides are equal. So saying this, let me say goodbye here. Today's class is over. Thank you all for watching and have a wonderful day ahead.